The moon, our closest celestial neighbor, a timeless symbol of mystery and inspiration. For centuries, it has pulled at the tides in our imaginations, its surface marked with stories of triumph and discovery. But beyond its beauty lies danger. The moon's surface is a place of extremes, searing heat, freezing cold, and relentless radiation. For the explorers who set foot here, every step is a calculated risk. Yet, beneath these perils lies something even more tantalizing, the promise of secrets hidden in its depths. Could the moon's most dangerous places hold the key to humanity's future in space? The moon is no longer just a destination. It is a gateway to understanding our place in the universe. And to unlock its mysteries, we must explore its most treacherous regions. Though the moon's surface has captivated us for centuries, its true secrets may lie hidden beneath. The moon's subsurface is a treasure trove of mystery, offering the promise of water, resources, and even clues to its ancient history. Unlike Earth, the moon lacks an atmosphere to protect its surface from meteor impacts, leaving it covered with regolith, a fine, dusty layer of debris. Beneath this layer, scientists suspect vast reserves of water ice, shielded from the sun's heat in the permanently shadowed regions of craters. These reserves of ice could serve as a resource for future missions, providing not just water but also hydrogen and oxygen for fuel. Unlocking these reserves is essential for humanity's ambitions of establishing a permanent presence on the moon and beyond. Exploring the moon's hidden depths requires cutting-edge technology. Ground-penetrating radar systems like those used in NASA's Lunar Reconnaissance Orbiter, LRO, and Chandrayaan-3 send electromagnetic waves into the surface, mapping the layers below. These instruments help scientists locate ice, rock, and other materials with remarkable precision. Thermal sensors and advanced drills are designed to extract and study the moon's subsurface materials. These tools are critical for confirming the presence of water ice and understanding its purity and accessibility, key factors for future lunar colonies. India's Chandrayaan-3 recently confirmed the presence of water ice in the moon's south pole, a landmark discovery. Meanwhile, NASA's ShadowCam on board the Korean Pathfinder lunar orbiter has provided unprecedented images of the darkest, coldest craters, revealing clues about what might lie hidden within. These findings not only deepen our understanding of the moon, but also set the stage for sustainable exploration. With water ice, humanity can create breathable air, drinkable water, and even rocket fuel, transforming the moon into a launch pad for deeper space missions. But what else might lie beneath? Could there be geological records dating back billions of years, holding clues to the moon's formation? Could the ice contain chemical signatures of ancient cosmic events, or even the building blocks of life? Subsurface exploration is not just about resources. It's about uncovering the moon's secrets and understanding its role in the history of our solar system. Every layer we uncover brings us closer to answering some of humanity's biggest questions. The moon's surface may be lifeless, but its hidden depths could hold the keys to humanity's future. As we dig deeper, both literally and figuratively, we uncover not just resources, but the knowledge to propel us toward the stars. The moon, as we know it today, emerged from a cosmic cataclysm. Over 4.5 billion years ago, a collision between the early Earth and a planet-sized object created a glowing, molten moon. But the story didn't end there. The moon's geological history, shaped by ancient impacts and volcanic activity, left behind resources that might hold the key to humanity's future in space. For millions of years, the moon endured a relentless barrage of asteroids and comets. These impacts not only shaped its surface, but also delivered essential elements, water, carbon, and other volatile compounds, that became trapped in its soil and rocks. But the moon's greatest gift may lie in its polar craters. These craters, shrouded in perpetual darkness, act as natural cold traps. Water ice delivered by comets and asteroids billions of years ago remains frozen here, preserved by the moon's lack of atmosphere and its extreme cold. Early in its history, the moon experienced intense volcanic activity. These eruptions created vast plains of basaltic rock, rich in minerals like titanium and iron, materials that could one day fuel human exploration and industry on the moon. Unlike Earth, the moon lacks an atmosphere and weather to erode its surface. This unique environment has preserved its geological history, locking away resources like water ice, helium-3, and rare minerals in its soil. In these dark, frigid regions, where temperatures can plunge to minus 250 degrees Fahrenheit, water ice has remained untouched for billions of years. These ancient deposits offer a glimpse into the moon's history and a resource for humanity's future. From fiery volcanic plains to icy polar craters, the moon's evolution tells a story of resilience and potential. Its surface holds not only the scars of its past, but also the resources to fuel humanity's future adventures into the cosmos. The moon has always been a source of wonder, but its true potential may lie beneath its surface. Beyond water, the moon holds a treasure trove of exotic resources that could revolutionize life on Earth and beyond. These resources aren't just scientific curiosities, they're economic and geopolitical game changers. One of the most promising resources on the moon is helium-3, a rare isotope of helium. Unlike other elements, helium-3 could fuel nuclear fusion, a potential source of virtually limitless clean energy. When fused with deuterium, it produces massive amounts of energy without the radioactive byproducts of traditional nuclear reactions. On Earth, helium-3 is almost non-existent, primarily arriving via the solar wind. But on the moon, where the regolith has absorbed billions of years of solar wind, helium-3 is abundant, particularly in regions like the lunar highlands. To extract helium-3, mining operations would need to scoop vast amounts of lunar soil, heat it to high temperatures, and capture the released gases. While the process is challenging, the potential payoff is enormous. Just 1 ton of helium-3 could power an entire city for a year. Beyond helium-3, the moon may hold valuable rare earth elements like yttrium, neodymium, and europium, critical components in modern technology. These elements are essential for manufacturing semiconductors, batteries, and renewable energy systems. On Earth, rare earth mining is often environmentally destructive and geopolitically sensitive. The moon, with its vast deposits and lack of ecosystems, offers a cleaner alternative, reducing our dependence on terrestrial resources. The moon is also home to abundant titanium, found in minerals like ilmenite. Titanium is incredibly strong and lightweight, making it vital for industries like aerospace and construction. Extracting titanium on the moon could support future space exploration missions, providing the materials needed for building lunar bases and spacecraft. The race to mine the moon is not just about resources, it's about power and influence. Countries like the United States, China, and India are already investing heavily in lunar exploration, aiming to secure their place in this new space economy. Lunar resources have the potential to reshape global economies. Helium-3 alone could power industries for centuries, while rare earth elements could break monopolies and stabilize supply chains. But this potential also raises critical questions. Who owns the moon's resources? How do we ensure fair access and avoid conflict over these treasures? Treaties like the Artemis Accords aim to establish frameworks for peaceful lunar exploration, but the rapid pace of technological and economic incentives could challenge international cooperation. The moon's resources, once a distant dream, are now within reach. Helium-3, rare earth elements, and titanium could transform Earth's industries, propel space exploration, and redefine humanity's relationship with our celestial neighbor. But as we look to harvest the moon's riches, we must balance ambition with responsibility, ensuring that the moon remains a symbol of possibility, not a source of division. The moon may seem barren and lifeless, but beneath its dusty surface lies a dynamic interaction with cosmic forces, one that could hold the key to humanity's future in space. Unlike Earth, the moon has no atmosphere or magnetic field to shield it from the relentless bombardment of solar wind and cosmic radiation. But this exposure has a surprising benefit. When solar wind particles, especially hydrogen ions, strike the moon's regolith, they interact with oxygen in the minerals, creating hydroxyl, a building block of water. This process has left a thin veneer of hydroxyl across the moon's surface, a hidden potential resource for future explorers. Meanwhile, micrometeorites, tiny fragments of space debris, collide with the moon at high speeds. These impacts generate intense heat, melting small amounts of the regolith and trapping water molecules in glass beads. Over billions of years, these interactions have created reservoirs of water hidden within the moon's surface materials. But the moon's ecosystem isn't just about water. The regolith itself, a fine, dusty layer formed by eons of impacts, holds incredible potential. Rich in silicon, aluminum, and other elements, this material could be the foundation for lunar construction. Scientists are already exploring ways to turn lunar soil into lunarcrete, a strong, versatile building material for habitats and landing pads. By using the moon's own resources, we could minimize the need to transport heavy materials from Earth, saving time, energy, and cost. Beyond construction, the moon's regolith could also provide valuable resources, including oxygen for breathable air and metals for manufacturing. This would transform the moon into a self-sustaining outpost, a stepping stone for humanity's expansion into deeper space. The moon's interaction with cosmic forces has shaped it into more than just a lifeless rock. It's a repository of resources and opportunities. By unlocking its secrets, we're not just learning about the moon, we're laying the groundwork for a new era of exploration and innovation. The moon, once an unreachable frontier, is now poised to become humanity's next home away from Earth. But turning this barren, hostile world into a livable outpost requires extraordinary innovation. How will we overcome the challenges of lunar colonization? One of the greatest obstacles to lunar colonization is the moon's dust, an abrasive, electrostatically charged menace. It clings to everything, damages equipment, and poses health risks to astronauts. To combat this, researchers have developed electrodynamic dust shields, which use electric fields to repel dust particles and keep surfaces clean. Autonomous rovers equipped with artificial intelligence will play a critical role, scouting for resources, preparing landing zones, and constructing habitats long before astronauts arrive. Spacesuits, too, are evolving. Lightweight, flexible designs are being developed to withstand extreme temperatures, radiation, and the abrasive lunar dust, enabling astronauts to work efficiently in this hostile environment. NASA's Artemis program is at the forefront of lunar exploration, aiming to return humans to the moon by 2025. Artemis will establish a sustainable human presence through projects like the Lunar Gateway, a space station orbiting the moon that will serve as a hub for deeper exploration. Meanwhile, China's Chang'e program has made remarkable strides, with landers and rovers already exploring the moon's far side. Their long-term plans include constructing a robotic research station and collaborating internationally to advance lunar science. Private ventures like SpaceX are also critical players. With their reusable Starship, they aim to support NASA's Artemis missions and enable large-scale cargo deliveries to the moon. These efforts are not just about visiting the moon, they're about staying. The moon isn't just a stepping stone. It's a launch pad for humanity's journey into the cosmos. Its surface is rich in resources like helium-3, a potential fuel for future nuclear fusion, and water ice, which can be split into hydrogen and oxygen for rocket fuel. With lower gravity than Earth, the moon offers an ideal staging ground for deeper space exploration. Establishing lunar colonies could pave the way for missions to Mars and beyond, reducing costs and advancing our reach into the solar system. Lunar colonization isn't just about science and survival, it's about vision. The moon, once a symbol of mystery and inspiration, is becoming the foundation for humanity's next great adventure. As we take these first steps toward living on another world, we move closer to fulfilling our destiny as explorers of the cosmos. The moon, Earth's closest neighbor, has revealed many secrets over decades of exploration. Yet, its most dangerous and enigmatic places, its shadowed polar craters, remain a frontier of unanswered questions. Since Chandrayaan-1's groundbreaking discovery of water ice in 2009, scientists have been captivated by the moon's hidden reservoirs. But despite strong spectral evidence confirming the presence and quantity of this water remains a significant challenge. In the moon's polar craters, some of the coldest places in the solar system, temperatures plunge to nearly minus 250 degrees Celsius. These frozen depths, untouched by sunlight for billions of years, should harbor ancient deposits of water. Yet, direct observations have been elusive. ShadowCam, aboard South Korea's Danuri spacecraft, is providing our most detailed images yet of these pitch-black craters. But questions persist. Why is water so hard to locate? Is it trapped beneath the surface? Or has it been sublimated by micrometeoroid impacts over time? To answer these questions, upcoming missions aim to explore these perilous regions firsthand. NASA's Artemis program will send astronauts to the moon's south pole by the mid-2020s, with plans to study the availability of water and other resources critical for sustaining human life. China's Chang'e program is also advancing rapidly, with plans to deploy advanced rovers and landers to investigate polar resources. These missions aim to unlock the potential of lunar ice for drinking water, oxygen, and even rocket fuel. Future mission concepts like ice mining rovers are being developed to extract and analyze subsurface ice. These technologies could pave the way for a sustainable human presence on the moon, turning it into a stepping stone for deeper space exploration. The stakes are high. If the moon holds sufficient resources, it could become humanity's first outpost beyond Earth, a hub for scientific research, resource extraction, and interplanetary travel. Imagine spacecraft refueled with moon-sourced hydrogen, enabling missions to Mars and beyond. But these possibilities hinge on answering one question. Can the moon's resources truly support a self-sustaining presence? The moon's polar craters hold both promise and mystery. Within their icy shadows may lie the key to humanity's future in space, a future where we learn to thrive beyond our home planet. As new missions venture deeper into these uncharted realms, each discovery brings us closer to solving the mysteries of the most dangerous place on the moon. The moon, our nearest celestial neighbor, has always inspired humanity. From ancient myths to the Apollo missions, it has symbolized possibility and wonder. But today, it represents something more, a gateway to our future in space. Exploring and colonizing the moon isn't just about scientific discovery. It's about preparation. Its proximity to Earth and its unique resources make it the perfect platform for humanity's next steps into the cosmos. From harvesting lunar ice for water and oxygen to building fuel depots for deep space missions, the moon could be the key to unlocking the solar system. The secrets hidden within the moon's most dangerous places, its shadowed craters and rugged terrains, might hold answers to questions about our origins, our survival, and our ability to adapt to new worlds. But this future isn't just about technology. It's about collaboration. The moon reminds us that exploration requires unity. No single nation or company can claim it alone. It's a shared frontier that belongs to all of humanity. As we venture into this new era, we must ask ourselves, what responsibilities do we carry? How do we ensure that the moon, a place of mystery and wonder, remains a symbol of exploration rather than exploitation? The challenges are immense, balancing progress with preservation, science with ethics. But the moon offers us a chance to get it right, to create a future in space that reflects the best of humanity. The moon may be just the beginning. As we learn to live and work on its surface, we lay the foundation for exploring Mars, the asteroids, and beyond. Every step we take on the moon brings us closer to becoming a truly spacefaring civilization. Yet, the moon is more than a stepping stone. It's a reminder of where we came from, a connection between Earth and the stars. It challenges us to dream, to collaborate, and to ensure that our exploration of the cosmos reflects the hope and resilience of humanity.
As we reach for the stars, the moon may be our first great leap into a sustainable future among the planets. Its mysteries beckon, its challenges inspire, and its surface may soon bear the first footprints of humanity's next great chapter.